So where were we? Talking about evaluating how technology, if it's good or bad. Let's go there. So we love technology. There are some issues with it that we have talked about plenty. Right? How can we cope with those things? I'll try and answer that question. How can we think critically? That's the whole point of this class, right? About those downsides that technology has, because we know it has so many upsides, so it's gonna stick around. We're never gonna get rid of technology, but how can we maneuver around the issues? So let's talk about some issues. I have some more anecdotes today. This is a bit more popular nowadays. Have we heard of deep fakes? Is that like a word that's in our lexicon nowadays? That used to be just like computer science people understood it, but now it's like a normal thing. So deep fake is when you can take a video, right? Take a video and you can change whose face is in that video. It uses machine learning to do that. Machine learning has gotten very powerful, especially recently. So it's like people were putting Nicolas Cage and everything for some reason. That was like the first meme about all this stuff. But that's kind of relatively recent that you could start changing videos, changing people's faces in videos. It was already totally common. Like, you could never trust an image, right? You could never trust an image before because Photoshop has been around for a very long time, and people are very good at changing faces in pictures. So, if you try to use a picture in like an argument somewhere, maybe somebody's like, "Oh no, that was photoshopped," and like that's common knowledge. But videos, at least, used to be pretty good evidence, like held up in court, stuff like that, like security cameras, right? Videos used to be proof that somebody really was somewhere and did something. But thanks to deepfakes, that's not really a thing anymore, right? Now you can change your security camera footage to show that somebody completely different was in the room and stealing the jewels or something, okay? So you can see how very easily this could be used for like fraud, for making hoaxes. That would be, I guess, less serious. And then like people really liked putting Nicolas Cage's face on everything for some weird reason, and you can continue with that, of course. So how do we cope with that? I guess we can't trust videos anymore. That's one reason. It's one thing we can say. All right. Have any of us try, are there easy tools to make deepfakes these days? Have any of us tried to make one before? I don't think I've looked into it, but maybe it's super easy now. Who knows? It's just it's a TikTok filter away from changing your face into somebody else's. So that's one thing to worry about, I guess. What else should we be worrying about? I guess as far as our information is concerned, we have to be cautious about the sources and where we're getting things, because this is the reason why your English professors don't want you citing Wikipedia, and the reason I don't want you citing Wikipedia either. Anybody can edit Wikipedia, right? Have you tried that? I've noticed some typos, and I've fixed Wikipedia in certain places. That's a thing that you could do. People update Wikipedia every day, which is kind of the reason it's so nice as well. It's like every article can get changed, and so if some new information comes out, it's like the first thing that's going to get modified. Like, you had an article, it had some stuff, and then some new things happen, and somebody 5 minutes later after the news article gets released, they start adding to the Wikipedia page. So it's like the ultimate news article. It's great. It's not meant to be cited though. So yeah, it's great that it changes so quickly, but that is also its downfall. Right? Anybody can modify a Wikipedia article. You can change it. You can give it weird information, give it incorrect information, right? So I could technically, we could go to the Clovis Community College website, or Clovis Community College Wikipedia page, and we could change, the picture of the college or the picture of the mascot to be, a picture of our cat, of my cat. That would be a thing that we could do. So that's why we can't really trust it too closely. But luckily, Wikipedia is really good with at least vandalism, as far as that's concerned. It's good at automatically discovering things that are easily known to be inaccurate. But sometimes it takes a while for, the change was so subtle that it needed a human to come along and get rid of the cat picture or something more serious. Okay? And so you'll see, the citation needed in the brackets a whole lot. Let this slide for now, but you should really be citing your sources. Tell me why this, you added this to the article, and that's how people improve it over time. So doesn't mean you shouldn't use Wikipedia, but the goal is to go to the articles, the ones without the citation needed attached to them. The ones with actual citations, go to the articles that Wikipedia is citing, read those, make sure that whatever was summarized on Wikipedia was even correct, and then cite those. Right? As long as you do your own research, actually visit the articles that are cited on Wikipedia, then everything's fine. If you use it to find sources, Wikipedia shouldn't be your source. Right? So that's kind of how we should be using things, and I'm sure you've gotten this lecture from an English professor by now, right? But that is a thing. We have to be cautious about our knowledge and where we're getting it. So, here's just a fun little thing that I saw when I was on Reddit once. Like somebody linked to an article for the California grizzly bear. Like there was a Reddit post about it, and I don't remember why. But it wasn't about the issue that is on here. Like somebody modified the page really quickly, and they added a line at the start. You see that? It's a little silly. And so that's the kind of thing that happens all the time on Wikipedia. And this was not this stuck around for a while, and for some reason it wasn't automatically removed. And so that kind of thing is the reason you should be cautious on Wikipedia. Humans have to eventually visit the web pages again and fix things, get rid of vandalism, stuff like that. Okay, so yeah, hopefully that makes enough sense. I know if you're getting this from your English professor, I don't need to stay too long on it. So okay, let's move on to safety stuff, because that's going to lead into the next set of slides. We're going to get into the Therac 25 stuff you've been writing about, right? So let's talk about car crashes and testing cars. If you build a car, you want it to be pretty safe, right? Eventually, when you make a car, you have to do a car crash test. You have to send a model of your car flying into a brick wall, essentially, just to prove that it's going to work. You got to take your little car. It was my best drawing of a car. You got to send it flying that way with a dummy in the passenger seat and the driver's seat into the wall. Okay, and that's very expensive. I think you can imagine. You waste a car at that point. You waste a wall too. So wouldn't it be nice to simulate car crash tests so that you didn't have to make as many real cars and drive them into walls? So why not do it in software for free? You just got to model the car, right? The issue lies in the fact that you would have to correctly model what would happen to your car if you were to really do it in real life. The only correct way to simulate that would be to simulate every single atom of that car, right? That would be the only correct way to do it, and you can't do that. That's impossible to put inside of a computer, right? You'd have to model every little detail of every little material, every different thickness of metal, every different kind of metal. Whatever's inside of a car, it needs to be modeled down to the nitty-gritty. And we can do that more or less well. We know a lot about physics. There's a lot of equations that you've learned about in physics class, right? But we can't model each individual atom of a car model, okay? That's impossible. And so you have to make simplifications. That's the whole point. If you're going to model your car crashes in software, you have to simplify the car. You're not modeling atoms, you're modeling every square centimeter or something of the car instead. And you have to trust that. And so the question is that all right? Is that fine? Is it okay to put all this inside of a computer somehow and run car crash tests that way? Is that okay? And so that is an ethical question, right? Should we be allowing this? There's arguments on both sides. You can ask your boys about it, but here's some pros and cons. One argument is eventually they are forced to run a real crash test on the car. So maybe because they're running a bunch of simulated car crash tests and getting simplified information but still useful information, maybe that will let them iterate very quickly on the different models of car, and they'll come up with a safer model in the long run to run the real crash test on. That's one way to think about it. That might be best. But then on the flip side of that, you can be well, maybe the simplifications of this modeling software are not the greatest, and they probably, if they really just did make a bunch of real iterations of their car model in real life and throw them into walls, maybe they could have really made a safer test, because they get better results from a real life test. So that's the flip side of that. And so maybe the answer is to use a little bit of both. Don't just do one real life car crash test. use the software to make a few versions and try out the versions, something like that. Right? So that's another thing that we have to worry about. Like our safety is now in a bunch of different ways, right? We're relying on computers for our safety. This is one way you might not have thought. Yeah. Any questions, ideas, comments about that? It's a weird thing to think about. Like these physical things, like all of our cars these days are modeled by somebody in like a 3D software, and then they made that. Hopefully that's okay. All right, more anecdotes. Let's talk about. I guess this is another safety thing. If you have, like, Google can totally do this. I think Apple can kind of do it as well. But if you have an Android phone, Google can totally delete an app that you have installed on your phone if they want to. They have the power to remove stuff from your Android device. And so the point of them having that power from like the terms of service or whatever, that's supposed to protect against malicious applications. Like think of an old person accidentally downloading an app that they think is one thing, but it's really going to like steal all their passwords or something. And then if Google notices that, they can like delete it from everybody's phone. Like that seems nice and safe. But there's also a question of like, I downloaded this thing. Should they have the right to get rid of it? Should they be allowed to do that? Because maybe it's just not an app that's malicious. Maybe it's an app that Google disagrees with. And so I guess that's something that's been in the news recently with Apple, at least. Did we hear about? I think it's a couple years ago now, but it's still something recent happened because of it. So maybe you've heard about it recently as well. But did you guys hear that Apple took down the mobile version of the game Fortnite from their app store? So they got rid of that. That was a while ago. And the reason that they did that was because of money. So wasn't a malicious app or anything. It was because Apple wanted like a lot of money from in-app purchases, and like you would have to like subscribe to the Fortnite game, I guess, inside of the app. And so they wanted a good chunk of that money. And the Fortnite developers were like, "No, you gave Netflix a really good deal. Why can't I have not pay you as much too?" And so there was like a court case that they settled out of, and I think they just recently added them back in like the European Union, but maybe not the U.S. I don't know. And so there's rules for every kind of app store, and if an app breaks those rules, like they don't want to give, they like ask you to buy things, and they don't give the like Google or Apple their fair share, then they can also get removed. This is just an example of that. So if you don't follow whatever rules that you're required to follow when you put your app on their app store, then they can get rid of them for you, which is unfortunate. And so like these are people like who legitimately bought the Fortnite game. Now they can't like download it on any of their other devices if they didn't do it already before it got removed. That's an issue, right? That's something you paid money for and now you don't have access to. So that's interesting. That's a thing to think about. Like, should we be giving that kind of power to our app store? Like, you've got the malicious apps argument, and then you've got the thing I've bought but that the app store didn't like argument, and those are kind of at odds with each other. So maybe the government should step in, like they did in the EU. So that's an idea. And then here's a fun thing that I saw. Once upon a time, Amazon. This might have been in the textbook. Amazon like has Kindles where people read stuff, right? Amazon forcibly removed copies of 1984 from customers' Kindles, which is super ironic if you've read the book 1984. So that's pretty fun. Yeah, so that's a thing. Maybe we should fight for laws where that this kind of thing is not possible. That seems wrong. But again, there's some reasons for it as well. So it's an ethical dilemma, as we know and love. Okay, so along the lines of phones and just like software in general, you can be forced to upgrade things. That's another thing that's very, very common these days. So like Windows 10, for example, which I miss nowadays. Windows 10 was an automatic upgrade from Windows 8. That was like the previous version. And they kind of did it without a lot of people's, without their approval. Like somebody just woke up one day, Windows 10 had suddenly been installed for them. So that's unfortunate. And then a similar thing has happened with like Windows 11. Like your computer just keeps bugging you. Hey, do you want to upgrade to Windows 11? Hey, do you want to upgrade? So sometimes the upgrades are forced upon you. In this particular case, that's a thing for Windows. Some software also forces upgrades. Like we all use Discord, right? Because that's what we have in this class, at least. Discord automatically upgrades itself the second you open the thing. So you can't have the old version. It's impossible. So this kind of takes away our control, in a sense, doesn't it? So the question is now, do we have control over what we put on our computer, the apps we install on our phone, stuff like that? And then you could, of course, argue both sides, as you can to all of these ethical dilemmas, right? An argument for forced upgrades is like the second there's a new version of something, people stop working on the old version. Like they expect you to like upgrade to the new version and get all the cool new stuff, including all the patches for security purposes. So older software has a bunch of holes that have been fixed by the newer software. And so one reason for forced upgrades would be like it would be nice to like have all that stuff automatically taken care of, and now nobody's going to hack my computer and get in through that old software. So that's one thing that you can use to weigh. That's like a pro. But a con would be like you've lost control as the consumer. You've lost control over the software that maybe you paid for, right? You bought this app and like you like this version for some reason. You didn't want the new thing, where maybe they made some changes or something like that. So that's a thing to think about. Do we have a right to keep an older version on our computer? Do we have the right to not upgrade? I guess, again, it's a weighing game, pros and cons. You can probably think of good scenarios in both at both extremes. Again, something to get your mind moving about. Any questions, comments about this? Have we experienced this? Something been forced? There you go. Yeah, so something to think about. And I got one more real example, and I want to talk about equity now. So hopefully we know what equity means. It's just the idea of like giving everybody equal access to things. There's a difference between the word equality and equity, and this is like the picture that everybody uses. This is more or less accurate. It's like with equality, everybody gets a box to stand on. They get the same box. It's equal, right? But with equity, it's like the people who need a little bit extra, they get more height, right? And so everybody's at the same level at that point. That's the point of equity. Everybody gets, some people, like, they need 2 boxes. Some people don't need any boxes to be able to do the same stuff. So that's the idea. So equity, there's a big deal with that and technology, right? Especially thanks to the pandemic. Like everybody was working online. Like everybody needed technology at that point, and some people didn't have it, right? You can imagine like a lot of low-income households don't have like a fast internet connection or a powerful computer that they could then use to like move on up in the world, which is unfortunate. Okay, like especially these days, like you need a cell phone, you need an email address like to apply for a job. That didn't used to be the case, right? You could just like hand in your resume in person or something and get hired on the spot back in the day. But that's not a thing anymore. Yeah, especially important during the pandemic, which could be still going on. Who knows? So like if you don't have a webcam, like back in the day when like everybody had to take a math class online, like all the math professors, they knew how easy it was to cheat, right? So they forced everybody to use like Proctorio or whatever that thing was. Have we been forced to use that before for a class? Like we had to like turn our webcam on, use some service, especially for like a math class where it's easy to cheat. If you didn't have a webcam, you couldn't like take your math class. You couldn't take that proctored test online. So that's unfortunate. So yeah, equity is a big deal. And so like if you guys ever become software developers, I want you to have this in the back of your mind. It's important to make sure that everybody has access, that you're writing your software in a way that's going to help everybody. And so on the topic of like pandemic proctor software, a lot of the time programs are written with like a majority group in mind, and that's unfortunate. Like programs are often written by white people and tested by white people, and that becomes an issue in certain cases, and I have a fun tweet on the next slide to talk about that. But like, so that means even if somebody gets the cool technology, like it's not, maybe it wasn't even tested for their kind of skin color, for example, and it won't work for them. And that leads to this kind of tweet. This person took a proctored test, and they're like, I'll just let you read it. It's like, everything was fine. It was just the color of their skin that was throwing off the software, which is disgusting. So when you guys become software developers, no excuses. You got to make sure you're testing your stuff, making sure that everybody gets a fair chance at things. Any questions, thoughts about that? All right. So if we're happy, or angered, I don't know. If we're good enough for now, let's move on to my next set of slides, and I think that's like halfway through these as well. So I want to talk about bigger issues with technology, like life-affecting issues, like people getting hurt now. So let's talk about the risks and bugs that created risks. Okay. So yeah. So a lot of problems in software. We've written a lot of code, right? We've written Python code, we've written Scratch code, and I'm sure it didn't do the right thing the first time, right? So we know how easy it is to mess things up, and if software is controlling safety critical stuff, how do we make sure, right? How do we make sure it's correct and doing the right stuff, right? Can have a lot of issues. So how do we keep using computers even when they're causing so many problems and they're so like it's so hard to get a program right? Like how do we trust them? How do we use them like in the doctor's office? How do we cope with that? How do we make sure it's all correct? So let me show you some ideas, some examples of things just going really, really badly as far as software is concerned when it's the software's fault. All right, this is a rocket. This is called the Ariane 5. It was launched in 1996, so probably before a lot of you were born. I was still a toddler, very, very young, I guess. And so this was made by not NASA, because we haven't heard of it, right? It was made by ESA, European Space Agency, so like our European partners in crime over there. They were working on their own rockets and stuff, called the Ariane 5, which implies the existence of Ariane 4, which we'll get to. And so their launch of the first Ariane 5 style rocket just went very badly. It took 37 seconds, like it launched 37 seconds later. It wasn't even that high up. It self-destructed. So that was back in summer of 96. Okay. So 37 seconds into flight, it was like, oh, issue, and it blew itself up because it thought the problem was so bad, like it was going to like go back down into Earth and like hit people, and like so it's going to blow itself up in midair to like limit issues. And this was an unmanned rocket, first of all, so like nobody died, luckily. But the cause of this issue was a bug in the software. There was nothing wrong with the rocket. It was fine. It was going to do the right thing. But it thought there was a problem, and it blew itself up because of it. All right, and so it was a lot of money. So this is like, if you adjust this for inflation, this was $370 million in 96 money. So a lot of money to go and like redo all this. So let's talk about the problem. What happened to make this, like, what was the bug that caused this thing to self-destruct? Crazy. So like when you're programming rockets, this is the kind of code that you write. You have to worry about like, should I call the self-destruct function, I guess. So, okay. Here's the problem with the Ariane 5 rocket. Here's what went wrong. They tried to take a 64-bit float and shove it into a 16-bit int. All right? We know what these words mean, but maybe I should explain further. So, a 64-bit float, it's a number, right? It's representing a number with decimals. That's what float means. That's what that type means, right? So it's representing a decimal number with 64 bits, 64 ones and zeros, 64 binary digits. All right, so that's something that it was storing. It's a number, 64 binary digits. And remember the float type. That's the cloud that can hold numbers with decimal places, like 3.14. It can hold like scientific notation stuff. It's like 5 times 10 to the 50. And what they did was they tried to shove that into a 16-bit number. They kind of like rounded it in a sense. They're trying to like round it off in a certain way, and for space-efficient purposes, like put it into a 16-bit number, which was 16 ones and zeros, 16 bits. And not only was it 16 bits, but it was an int. So they got rid of the decimals as well. So they kind of had to really round it. So like, remember the int cloud, what kind of things can you put in the int type? You can put whole numbers only, right? 0, 42, negative 42, and like you run out of room a whole lot sooner than you would with 4 times the number of bits, yeah? So that's an interesting issue. And the reason the problem occurred is that number that they were using and trying to shove there, it overflowed, which means there wasn't enough space to really represent it in 16 bits. That was the problem. And the number was a very important number. It was a number that represented, apparently, the horizontal velocity of the rocket, which I assume, let me draw a picture of the Earth. Here's what I think that the horizontal velocity means. Like, here's Europe, there's Spain, Italy, there's the UK, Ireland. So here's the rocket launching off. It's trying to go this way, out of the Earth. So it's going up that way, and it's blasting off. And I think that horizontal velocity means like relative to the Earth, how fast is it moving sideways relative to the Earth? Because like it's going to launch off at like a bit of an angle, probably. And so that's what the horizontal velocity means, like how fast are we going relative to Earth, not like straight up, but like sideways. And so that's the number that they tried to, like, from the sensors, they got this number. They tried to shove it into a smaller place, and there just wasn't enough room to shove it there. And so it took a very big number, and it like cut off some pieces of it, and it made it look like it was a small number, I think. Right? And so the rocket thought it was moving a lot slower than it really was, and it's like, okay, there must be something wrong with my propulsion system. I'm going to blow myself up now. Okay? That's the problem. So that's what happened, and that's the issue. So it overflowed, because there was only so much room. Like, there was only so much. Let's pretend we're working with 4-bit numbers. Like, the smallest 4-bit number is 4 zeros in binary. The largest 4-bit number is 4 ones. And then the second that you try to, like, add a number, like you only have 4-bit numbers, let's say. The second you try to add 1 to, in binary, the largest 4-bit number, you overflow, we say. And so watch what happens. If you only have 4 bits to store something, the second you add 1 to this, let's do binary arithmetic. 1 plus 1 is 2, so that's 1, 0, carry. 1, 0. 1 plus 1 is 2 again, so 1, 0, carry. 1 plus 1 is 2, 1, 0, carry. 1 plus 1 is 2, so 1, 0 you carry. The answer would be 1 with a bunch of zeros, but you only have 4-bit numbers. You throw away that one. And so I was like, oh, okay, we're not going fast at all right now. Our velocity is 0. See that? So that's a problem. And the reason that this bug occurred, that they didn't find it, is they copied code. They copied code from the Ariane 4, which was unfortunate. And back then, they didn't think that the horizontal velocity number would get that large to need more than 16 bits. That was their thought process. And apparently the Ariane 5 had a faster propulsion system. And so it overflowed. It thought like it was going not as fast as it really was, and it blew itself up because it thought it was going to like crash. So a software bug. Just, like you can imagine like this was like one line of Python code or something. One line cost over $250 million. Crazy. So yeah, any thoughts about that? Weird. So yeah, that's a place you could go into if you're a computer scientist. You can go into like mission critical software, and nowadays like you can imagine like they've come up with some rules to make sure this never happens again. Okay, so there's that. Relevant to us because like we just had like a what was it called? Primary election. We're gonna have a normal election later in the year. Voting systems are electronic in certain places, not really in California, but there's some issues with electronic voting systems, and that's a bit of a problem, right? So from our textbook here are some anecdotes, some thoughts about voting systems. So back in the day, here are some examples. Some electronic voting systems, they just crashed. They just straight up crashed, and voters who were trying to vote just couldn't vote that day, which means they lost out. So that's unfortunate. That's really not good. Hopefully they use some sort of backup system. And so that ruins the show if that ever happens, and that's a software bug. That's a problem. Or like if you lose power, just think about that. Like if that's the way that people vote, now you can't vote suddenly. That's the thing. One county, I forget the state, but a county lost more than 4,000 votes because the memory of the machine, like too many people used that machine to vote and it couldn't remember all of their votes, which is disgusting. So that can flip an election, that kind of thing. So maybe paper is better. But these are all problems in the past. Hopefully people have fixed this. In Texas, in one of the Texas counties back in an election a while ago, a bug in the voting system software, it accidentally, in quotes maybe, generated 100,000 extra votes for a certain candidate. That's a problem. Of course, they would catch that, like, okay, that's more than the people who live in this county, but that's a huge issue, right? So that is maybe a reason we shouldn't trust electronic voting systems. But if you iron out all these issues, eventually maybe it could be safe and correct. Okay. Another bug in voting system software caused, this is the worst one maybe. One voting system had a bug where you click the button for one candidate, you wanted to vote for this person, it casted a vote for the opposite candidate. So that's horrible. It's like the opposite person wins now. And so, yeah. These are like just bugs that I think you can imagine were probably easy to write. Like you thought the software was correct. It's like you thought your Python program, you thought your Scratch program was right. But now suddenly, oh no, it didn't work, and you just didn't notice ahead of time. Like you gave it to the users, and now they're using your software, and bad things are happening. It's just so easy, right? It's very, very hard to write software that's correct, that's safe, that can't be messed with, that is never going to do anything wrong. So that's a problem. There are ways to make correct software. We've developed more over the years, but this causes people to lose faith in things like this. And this is maybe one reason why California still does a lot of paper voting. But some places, maybe it's a cultural difference, maybe they've never had any issues, but in Estonia, they can vote for their leader. I forget if it's a prime minister. No, it can't be a prime minister. You don't vote for those. Maybe it's their president or something. In elections, Estonians, they vote online, and that's fine. They just log in, and that works for them. No issue. So, yeah, maybe that's what we're going to all be doing one day. Fun ideas. So at least nobody's getting hurt with this one and this one. But let's fast forward to something that you wrote an essay about, right? Or about to turn in. Well, let's talk about the Therac 25, because this is the one, right? This is a bug, software bug. People got hurt. Very, very sad. All right, so let's spell all that out. I'm sure you've read the article, hopefully by now. But let me just give you the quick version of it all. Okay, so Therac 25 was a radiation therapy machine. So people had cancer, they were coming and getting treatment for their cancer. And this machine was controlled electronically, digitally by a computer. So it was back in the 80s. This Therac 25 machine was first made in 1982, and the first documented problem with it happened in 1985. So in theory, it was happening the whole time. If you remember reading the article, the bug existed the whole time, and so probably plenty of undocumented issues happened with it before then. But this was a bug, a very, very horrible bug. Errors in the design of the system as well as the code, just the combination of those two things. They ended up giving people too much radiation, 100 times the amount of radiation they were supposed to get. And that is very sad. All right, so just the ultimate irony as well. You're coming and you're giving radiation therapy to treat your cancer and make you better, and you're getting so much radiation accidentally that you get more cancer. So that's really, really horrible, and people their lives were cut short because of this bug. And so it's definitely important to talk about in this class. So the issue with Therac 25 was, again, they reused code. Again, they copied code and they shouldn't have. All right. It was also, there was a change in the way the machine worked. Right. So I don't know what this really looks like, but when you get radiation therapy, there's a little radiation gun that's shooting out radiation at you when it's turned on, and The bug was that, right, this gun, when it was supposed to be in the off position, it wasn't. While people were like changing the radiation levels on the computer, it was shooting out way too much radiation. But the old version of the Therac 25 machine, like Therac 24, Therac 20, whatever it was, it had a mechanical thing. It had a hardware lock here, like a little strip of lead or something, to block that excess radiation while like the beam was being changed in a certain way. They got rid of this little hardware blocker on the Therac 25 because, like, oh, it works so fine right now. Let's just like get rid of any extra costing things. They did that. They kept the same software, but it had that bug they didn't know about because they didn't see it with that hardware failsafe. They got rid of the hardware failsafe, and now it's giving people too much radiation. Right. So that was more or less the problem. It was just a bug, right? I think you can imagine like it was probably only a couple lines of code, but this legitimately killed people. So we should. Uh, that's why I'm having you write an essay about that. Any comments, thoughts that you want to say about this? This is a thing. Safety is an issue. We have to worry about that kind of stuff. So okay, let's. We've talked about a bunch of problems. Like this is probably on our mind for the essay anyway. So let's get into peer instruction groups, please. And I have a little debate question for you. You can debate yourselves. So please go to the written ice page, and I'll stop attendance after you've done that. So make sure you sign in for attendance too. Let's go to the written ice page, and I'll clear it out. And you guys can write together as a group if you'd like. It's not a problem. But I would like you to get together and discuss the following little debate question. Debate with each other. So when you have issues like this, right? Somebody needs to be blamed, right? Somebody needs to get sued, surely. So, like, whose fault is it? Is it the programmer's fault for introducing this bug? Is it the programmer's fault when something bad happens and people get hurt? Like, what could they have done? Like, surely they didn't mean to, but, like, who's going to jail? Should somebody go to jail? Is that a thing? So, I'd like you to talk about this as a group. Is it the programmer's fault when something bad happens and people get hurt? Give me a good argument for yes, and here's why. Like they should be going to jail, and like this is what they should have done otherwise, or like no, they shouldn't. Like this shouldn't really be all on them, and here's a reason why. All right, so try to come up with at least one good argument for each side of this debate. All right, so kind of debate with each other maybe, and write in those on the written nice page, please. And so take some time to discuss that. It's a bit of a heavy topic today. Try to put yourself in the programmer's shoes. Another thing to think about is like maybe you're working at a big company. Was it just one person's fault? Alright, that's my timer. Take another minute, or a few seconds at least, to like press submit, finish synthesizing your thoughts, and then let's see what we're thinking. See if we came up with some good ideas. Alright. Dun, dun, dun. Yeah, let's see what we're thinking here. Argument for the people to be at fault. Engineers, managers, and programmers. Yeah, good. Good that you're thinking about multiple people. There is not just one person involved. That is a good answer. Even if there's somebody at fault, they should have been safer. Like there's multiple people to blame, and they should have not made those mistakes. So they are at fault. Good. Argument for maybe it's the company itself. Like maybe that's what you should be suing. I guess not like an individual person. That's usually what happens. But yeah, let's see some other thoughts. I think the program should be at fault if the code was being used in the proper fashion, because that means they didn't confirm that their work worked in all cases. Yeah, exactly. Like they should have been testing it. Somebody should have been testing their code, right? That's how that should have worked. If that was the normal use case, they should have known, right? Or maybe it was being used improperly or in a way that they weren't aware of it. That was kind of what they were doing with their Act 25, honestly. They were like, people were like inputting things too fast, like faster than anybody tested it. So that's another argument for like maybe it's not their fault. Yeah, cool. So yeah, let's look at one more. Let's look at group number 10. So yes, they're at fault because they wrote the code that caused the error. Good. Yeah, that's pretty logical, right? But then, yeah, the question is like, do you know who inputted that code last? There is a way to know. You can track the changes for everybody's software. That's a thing. So if you do know that, is it their fault? But there's also the question of like maybe the line that caused the issue was fine before, but somebody changed the line above that. And now that led to like a cascade effect. So now, who knows? Isn't that funny? Maybe not funny, sorry. So yeah, that's one reason to think that somebody's at fault, and then another reason to think that they're not at fault would be like, it's the company's fault, maybe. They should be taking precautions. Good. They should be testing that software. Very, very good. And that's exactly what I'm going to get into next. So thank you all for writing your ideas. I appreciate you. So let me stop that like I promised. And here's some stuff that I wrote down. Is it the programmer's fault when people get hurt? Like, the question is like, who do you blame? Do you blame the whole company? Do you blame just the one person who wrote the line? Like we've been saying, like maybe it's hard to tell. Like it was a combination of like a multi-person effort for this error, this issue that happened, and that's most likely the case in all large software, including probably the S24 machine. So yeah, in the real world, a lot of people they're like working on big teams, like they're working in big teams on little chunks of the software. And those teams don't usually talk a whole lot. So like they think that their little chunk is correct, but like when in combination with the other team's chunk, it doesn't really work right. And so that's a hard problem to solve. Right? It's possible that the people working on their little chunk, they don't understand the big picture of the software. And so maybe that's a reason to not blame them. Right? But it's somebody's fault still, right? It's probably the company as a whole's fault. So we all know by now how easy it is to mess up in our programs and make bugs. So what is the solution? Even if we are going to sidestep the issue of who to blame, maybe like you should just be allowed to sue the company or something. But the solution is always going to be you should be testing the software ridiculously, right? You should be. There's also a concept called verification, which is slightly different to testing. Those are the ways. These are the things that people use in the real world to make sure that their software is correct. It's got to be tested, and then like if it's very mission critical, it gets verified as well. So. They might seem like these two words are synonyms, like in real life they're kind of synonyms, right? But in computer science, at least, they are not. So let me tell you the difference between testing and verification, and I'll have to do that across lecture. So I'm going to talk to you about testing first, because that's like, it makes a lot of sense, and so it should be pretty straightforward. What we should be doing is testing our code, and here's how you do it. Here's what it means to test something, right? It's like you have your code, and you kind of think of your code as a black box. Here is your code. Your code, it's a box. And you don't really know what's inside. It can be a three-dimensional box, that's fine. What you do is, to test your code, it's very simple, right? You give, your program takes input and produces output, right? Maybe it's complicated input and produces like radiation output, but it's still input and output. Like, maybe you give your code the number 42 and it does something with that as input. Maybe it spits out 13 or something. And then the job of a tester, the way that you test something, is like you say, like, I'm going to input 42 to my code, and then you think really hard about what should be coming out when you input 42. What should the output be? Like, you run the idea in your mind. What should have happened? Like, okay, yeah, the answer is supposed to be 13. And so you check that, and you confirm that. The output really was 13. It's like you run the code in your mind, right? So that's pretty much what it means to test something. You give it an input that you're like hard coding, like I know what the answer should be for 42. It should be 13, and then you confirm that like you really got 13 out the other end. That's the answer. That's how you test it, right? Of course, it doesn't catch every error unless you have a really really nice test, because you can imagine like even a box that like if your code takes a number, like you don't know if it's perfectly correct unless you try it on every single number ever, and that's impossible, right? So usually there's a way to like just make a few tests to get pretty confident that things are right. And I'll show you that on the next slide. So yeah, it doesn't really catch every issue, but it catches a lot. And so it works for most purposes. Sadly, in computer science, and if you've taken a computer science class by now, you've probably been forced to write tests, or you're about to be soon forced to write tests. And people sadly hate writing tests, because like, I want to do the cool stuff. I want to write the real program. I don't want to like make sure that the program works. That's kind of boring. So hopefully this is a view that we can change together one day. But that's an issue that's blocking things from getting tested. So yeah, that's all a test is. Like that's one test, and you just do that a bunch of times. Like, all right, 43. That should produce the number 14 or something, but like maybe your code produces the number 33 right now. So you'll notice like, oh, it should have been 13, so it fails that test right now, and so you gotta go fix the code or something. That's the idea, right? So this is essentially, if I spell it out, this is what it means to be a test. Here's an example test. It's like you try the input of 42, and then you confirm, you make sure that the output is like it was supposed to be 13 or something. All right, that's what it means to be a test. That the output is 13, and like that's one test. And you make a bunch of those in a bunch of different ways to confirm that you're doing the right stuff. Right? Does that make sense? That's one way to test code. And so let me give you an example of let's write some code and let's test it really quick. I haven't shown you how to make like if statements in Python yet. So we're gonna have to go back to Scratch. So I lied about saying we're done with Scratch. This is like the last time we're gonna use Scratch because I need conditionals. That's what it means to test something. Like that's what it means to check. Hey, was it 13? You gotta like do an if, right? So let's go to Scratch and let's write a simple program, right? Let's write a simple program. Let's make a block. Let's make a block that's called multiply numbers from 1 to blank. And we'll do that, right? So 1, 2, 4, let's say. Like the user can put whatever they want in here. And this block is supposed to multiply all those numbers together and like output the answer. Okay. So let's make that block first. So feel free to follow along if you'd like, but I'm going to do it in Scratch. I'm going to go to scratch.mit.edu one last time. Now I'm going to make that block. Multiply the numbers from 1 to n block. It should work for any n. Come on, little Scratch, you can do it. I feel like it's taking longer than it should. Maybe I should refresh it. There we go. Who knows what happened? Alright, so I'm going to make a new block. I'm going to call it multiply the numbers from 1 to, and then have a blank. There's a number input right there. Add an input. I'll call that thing n. And I'll click OK. So there's my block. Now I can use it a bunch of times. I can run it as many times as I want. And I have to say what it means to run it, like to give a definition for it. From 1 to 4, from 1 to 5. Like it should work for all those numbers. And so what does it mean to multiply all the numbers from 1 to some n, right? Where n is like an input to the block. Let's figure that out. Well, here's how you do it. We're going to make like a product variable. We're going to multiply stuff into it. We've kind of done this with sums before. I forget if we've done it with products though. But let me just do it really quick. Like we're going to have the number that we got from the user. I'll place that into like a variable called num. So like the 4 will go into the num. And then product, because I want to multiply into product, I'll start it at 1. So like it's not going to affect anything. Like that's the first number that it should be. And then I'll keep on multiplying num into product. That'll be my algorithm. Like multiply num by 4 or product by 4 now. And like that was the first one. And then I want to multiply 3 and 2 and 1 into it as well. So I'll just subtract from num. So like make it 3. Now it'll be doing it backwards, but it'll still get the right answer, right? Now I'll multiply 3 into product, make it 12. Now make num 2. Multiply the 2 into product, make it 24. Now make num 1. Technically you could stop now, but we'll just one last time multiply the 1 into product. Keep it as 24, because why not? Sorry, not 42, but 24. And then subtract from num, because this will be a loop. And then because it's 0, like we don't want to multiply 0 into product, that's when we want to stop our loop. Yeah, so like that's going to be the code. I'll just do that really quick. So I'm going to make 2 variables, one called num, and then one called product. I'll just rename the default one to product. And I might as well like check them. Why not? And so when we run this block, it jumps up here to this code. I don't think I've shown you this before. It sets this little n thing. It's like a special variable for the definition. Like it'll be like if we run this block, it'll jump up here and have n be 4. Or if we run this version of the block, it'll jump up here and it'll have n be 5. And it's just whatever the user gave you right now, and you got to work with it. Sadly, this variable is not like a normal variable where I can like subtract from it like I want to. So I'm just going to shove n into my num variable. That's what I'll do. So set num to n. That's what I'll do there. Set num to n, and then also set product to 1. Work. And then I'm going to repeatedly while, right, until num is 0, I'm going to do the following. So I'll do a repeat until the num is 0, I guess. That would be a good one to do. Num holds the thing. It's going to change, go from like 4 to 0 if the input was 4. So repeat until num is 0, the following process of multiply num into product, so set product to be whatever it is times num, and then increment num, or sorry, decrement num. So set product to be whatever product times num is. So operators times. This is all like review. We're gonna test this in a second though. Set product to be product times num. It's like gonna multiply the 4 in, the 3, the 2, the 1, etc. into product, and then we want to stop. Eventually, we want to multiply the next number. First, we multiply the 4, then we want to multiply the 3 next, the 2 next after that. So keep on subtracting as well from num. So change it by -1. Okay, and then after this is all done, once num is 0, product holds the right answer. So we can just have the scratch cat shout out the product. Probably that would work. So I can say product for 2 seconds or something. So say product for 2 seconds, and that looks like the code that it should be. I think that's fine. And so now, if I run this block, like if I click this one, it will jump, right, from 4. 4 is going to get shoved into this n special definition variable thing here. And then I'll start num at 4, because that's what n was, product at 1, do all this stuff. If you'd like to watch it work, we can. We can have a wait block. That's totally fine. But if I click this, you can watch it like multiply, multiply, multiply. That's like it's done, and it says 24. So that's perfect. It's doing the right thing. I think that's the answer, right? And then for 5, that should be times 5 more. So like, I forget what that is, but we can watch it work. It's changing, it's changing, it's changing. And apparently it's 120. Cool. Right? So that seems to be doing the right thing, right? But our question now is, like, sure it's working for 4, sure it's working for 5. Does it work for all of them? Do we trust it? So now we want to make tests, right? So here's what we want to do. We want to make some tests, right? And so let's do the 4 and 5 tests. Those are fine. Those are already there. It's like, all right, essentially what this means is, let me just write them as comments. Like, this can be our test as a comment. Like, make sure this gives back 24, right? That's like a test. That's one test. Does that make sense? So that should give back 24. Another test for this one would be like, make sure this gives back 120, because that's what the real answer is. Make sure this gives back 120, and it does. But that might incorrectly lead you to believe that like this is perfectly correct. A good thing to check after that, like some normal cases, are corner cases. And this is like where almost everything's right, but some weird things are happening. It's like where things are almost correct, almost not correct. Like maybe the inputs are bad. Think about those. Think about where the program is about to do something different. Like a corner case would be set n to 0, right? Multiply all the numbers from 1 to 0, because it's going to repeat, it's going to skip the loop in that case, right? Or like have n be 1, multiply all the numbers from 1 to 1, so then it'll run the loop only once. Make sure that still works. That's the kind of stuff you should watch out for, okay? So those are some good corner cases, like 1, 0, and 2. You just go and you just like confirm, like what should this answer be? Duplicate from 1 to 0, from 1 to 1 to 1, 1 to 2. You'll try all those. Oops. It's like, what do we want to have this give back? Like, what does it mean to multiply all the numbers from 1 to 0? Should this give back like nothing? Should it yell at the user? Maybe this should be an error, right? Error case? And that kind of informs what we should be doing. Like, what's going to happen here? It's apparently going to give back 1. Maybe we should change that. And that test kind of changes what happens now. What happens now? Multiply all the numbers from 1 to 1. It'll run the loop once. So that looks like it's working. That should give back 1. And then this one should give back 2, right? And so these ones work, 1 and 2. But like this one, multiply all the numbers from 1 to 0. That makes no sense. Maybe we should stop the program and like yell at the user. There should be an error. And so that would be a test, right? Checking that it's doing the right thing. It's like if our n here, or our num or whatever, we should like stop. How can I do that? Oh gosh. Do that, maybe. So if num was either num or n, because num has been set to n right now. If it's less than or equal to 0, so maybe if it's less than 1, then it makes no sense, right? If num is less than 1, it's like an error case, right? Maybe we should shout at the user, be like, no, doesn't work. All right, invalid input, something like that. And it will like stop the program or something. That's in control, right? Stop all. So that might work. That might test. That might fix this test, right? Let's move all these out of the way. Boop. So now it says invalid input. That's perfect. Whereas all the other ones, they still work. They give back the right stuff. So it's your job to make a bunch of tests that kind of look like that. You can also probably test, you're going to want to test very incorrect cases, okay? Like a negative number. And that actually would have caused an infinite loop before I did this check, wouldn't it? If I got rid of that for a split second, kept the old code before the error check, if I tested to multiply all the numbers from 1 to negative 42, this will never stop. Look at how the num is getting smaller and smaller and smaller, just forever and ever and ever, really fast. So this is another error case, right? So that should give back an error rather than run forever. And that is again going to be a check on the input number. So kind of the tests, when we're thinking about writing tests, that like makes us make a better program, doesn't it? That's pretty cool. So now if I add this in again, it's like, oh, okay, num, a negative number was totally less than 1. So let's just confirm that that is going to do that. Invalid input now. And then everything else still works. And so yeah, the name of the game is like try some corner cases like those. That'll help you like think of error cases as well. Test incorrect cases. And then just test some normal numbers like we did. We tested 4, we tested 5. And then we made sure that those gave back what we expected. And so once you do all those, you kind of like hit every block in the code. Like you've had some inputs that run this if statement, have it be true, the if block, make it be true. You have some inputs that run the loop 0 times, 1 time, and then multiple times. And then after you've done all those, you can be pretty confident that's going to do the right thing for any other input. You see that? That's the point of tests. What you do is you always compare what you got back from your code with what you're expecting to see. Like you got to run the code in your mind or think about the problem in your mind first as well. That's the idea. Like 4 should have been 24. That's a check. All the numbers from 1 to 1, that should give back 1. All the numbers from 1 to 2, that should be 2 times 1 is 2. So those are the kinds of tests that you'll write. Okay? Any questions about that? So you can be pretty confident now that this block is doing the right thing for every case. Can't we? So I'll save that so that you can look at that later if you'd like. And I think that's all that I want to say. So we made a bunch of tests. We made a block, and we tested that block, and that kind of informed, that told us like to add some stuff. Like we needed that to make our tests pass. So it's like a give and take kind of game between writing tests and then changing the code, making sure the tests still pass. Like it helps you. It really does. So think about testing your code as you're writing it. That is my hint to you. So yeah, I think that's where I want to stop for the day as far as the lecture is concerned. Are there any questions about anything we've talked about before I switch gears? Because I want to show you a new assignment. Where is my browser? There it is. So you got an essay due, so let's give you a new essay. This is going to be a longer essay, right? So mentally prepare yourselves. And I've talked about this before. This is your fallacies essay, right? So you're going to go on social media and find fallacies. So do not be alarmed. This is a 1,000-word essay, but you're going to copy and paste a lot from the internet because I'm going to ask you to go and find stuff on the internet. You can totally quote those things, yeah? So that's the reason it's 1,000 words. And I'd like you, first of all, I'm going to explain as best as I can, but you need to read all these directions. There are a lot of requirements for this essay. You have to make sure you do them all to get a good grade, right? So make sure you read those directions. That is on you, first of all. Let's see, what else do I need to say? So yeah, a lot of bold stuff. Just read it all. I would like you to find fallacies, right? Find fallacies on social media. So if I reopen my fallacies essay, where is that? Is that in this one? Fallacies, crime, and security. Remember what a fallacy is? It's like an incorrect argument. Like you have the false dilemma fallacy, like this. You have circular reasoning fallacy. You have, of course, ad hominem fallacy, which exists on the internet so much. I'd like you to find those, right? So, excuse me. Let me read the rest to you. So yeah, there's a bunch of requirements. What I want you to do for this essay is find 5 fallacies in arguments posted on social media. So like, go to Facebook, go to Twitter or X or whatever it's called these days. Go to Instagram, look at the comments. Go to YouTube, look at the comments. There are so many people saying incorrect things on the internet, right? I want you to find those things. So, there's plenty more fallacies than we talked about in class. Here's a larger list. And you could find any of these that's on Wikipedia. You can find any of these. Just understand it first, of course. You're welcome to find any of them. And you could have your topics on anything, all right? You could pick anything, like whatever you're interested in. Go find fallacies in people's comments on those things, okay? If you are running out of ideas for some reason, here are some things that you could search for that are computer science related, not required. It might be easy to find people writing arguments with fallacies in them about these things like robots taking people's jobs, self-driving cars, they're great or they suck, stuff like that. There's a lot of heated arguments there and people using fallacies. So look into those if you're interested, but not required. Just like pick stuff you're interested in, like that you're looking at already while you're on your social media apps. So, all right, here's your idea. So you're going to find 5 fallacies, like figure out like, okay, this is circular reasoning, this is ad hominem, find a bunch of them, right? Find 5 of them somewhere. And here's how I want you to structure your essay, all right? Like, do the normal sandwichy thing, like have an introduction, have a conclusion paragraph, and then in the middle, I would like at least 5 paragraphs for one for each fallacy that you find. So like multiple paragraphs, but at least 5, each containing the following, right? So I want you to quote the social media post that you found with a fallacy in it, and then like give me background, explain it to me, analyze it, tell me why it has a fallacy, and give the name of that fallacy, right? This one is circular reasoning. Here's why. Here's the context. This makes sense, right? That's what you're going to tell me, okay? So provide the name of the fallacy. Remember to do that. Just don't be like, this quote has a fallacy in it, and then move on. Right? It has this particular circular reasoning fallacy, and here's why. Okay? That's what you got to do for me. So that's the bulk of your essay. Introduction, conclusion, as you would normally do, but like each paragraph, quote a social media post, tell me why it has that fallacy. Okay? Does that make sense? Yes.
Do you need links to the social media post?
You could if you wanted to, but as long as you have a quote, I guess technically I could search Google for that quote and find it.
Okay.
So you don't technically have to cite it, but you could if you wanted to. So yeah, that's what I want to see. And then my last requirement is that I know that people shout at each other on the internet all the time. So don't pick too many ad hominem fallacies. You can use only max 2 ad hominem fallacies out of your 5 total fallacies. Okay. People saying mean things to each other is so easy to find on the internet. That's not useful to me. Okay? I want you to find the harder fallacies as well. So you're finding 5 fallacies total on any type of social media, and you're going to quote them. You're going to talk about why they have that particular kind of fallacy, and you're going to name the exact kind of fallacy that you saw. Okay? Any questions about that? No citation requirements. Just like you're going to quote stuff. I guess if you want to quote the user on Twitter, you can totally do that, but that's not required. Just be like, this person said this, and move on. Okay. So 5 fallacies, 1,000 words at least. Shouldn't be hard, right? Because you're quoting stuff and analyzing a lot of things. But that is, I think, what I wanted to say. Okay. So that'll be due in 2 weeks. So you got time, plenty of time to do it. But oh yeah, also this is week 12. This will be after spring break, won't it? So technically you have 3 weeks. Nice. So yeah, my students in the fall they only get 2 weeks. So you guys get an extra week out of this deal. So no excuses. And let me know if you have any questions. I know that it might be hard to start searching for this kind of stuff, but hopefully once you start looking in places, it'll be more and more easy to find things. Okay? Any more questions about this essay? I hope that it'll be a fun one. Just find stuff that you're interested in that people are saying bad things about. That's just easy to find and interesting to you, I hope. All right. So if you're good with all of that, that is what I wanted to release today. I'll release your next programming assignment next time. So that's all I've got for you.